Determine the vector, parametric and Cartesian equation of each of the following planes. So we'll take them one by one. So now I've taken up part A of our equation. Determine the vector, parametric and Cartesian equation of each of the following planes. Part A was passing through the point P 1, -2, 5 and Q 3, 1, 2 and parallel to the line with the equation 2ti plus 4t plus 3j plus t plus 1k, where t belongs to real numbers. Now, I'll begin with Cartesian equation in this case, right? So we'll try to write the Cartesian equation first. Now, to get the Cartesian equation, we know for any particular plane, Cartesian equation is of the form of ax plus by plus cz plus d equals to 0, where the normal is given by ABC, right? So that is the Cartesian equation, which we'll try to figure out from the given information. Now, to find normal, we need two directions, right? So one direction is PQ. So let's get the direction PQ first. So P to Q, the direction will be what? 3 minus, let's write down, 3 minus 1. 1 minus minus 2 makes it plus 2. 2 minus 5. 2 minus 5. Okay. So that is 3 minus 1 is 2. 2 plus 1 is 3. 2, this is minus 3. Right. So we got one direction, PQ. Now the other direction we can get from the line itself, right? Now if you see, the line has got these t terms. It's kind of confusing the way it is written. But I think we can make out from here itself. So one direction component here is 2t, the other one is 4t, right? And the third one here is just t. I, j, k are your unit vectors, correct? So let me write down direction for the line as d1. Is it okay? So as I was mentioning, 2, 4, and 1. Clear? So we got the second direction. Now let's find the normal. So normal is the cross product, right? So basically normal is the cross product of these two directions. To find cross product, some of you will do matrix, some of you will learn different ways. Here is a quick way of doing it. Let me show you that. PQ, right? So P is this. We start with the center value, which is 3, and we write here 3, and then minus 3, right? And then 2, and then end at 3 itself, correct? Similarly, for the second, we start at 4, 1, cyclic order, right? 2, and then end at 4. Now, the components which give you the ijk components for the normal will be positive when you multiply these, right? And negative when you do the other way. Is that clear? So let me show you that, then we will see. So the positive components, 3 times 1 is 3. And 4 times minus 3, that will be negative. But when I do 4 times 3, negative 12, negative of that will make plus 12. Is that clear to you? So that is how I am going to get my normal. So minus 3 times 2 is minus 6 and take away 2, right? And 2 times 4 is 8, and then we'll take away 3 times 2, 6, right? So 2 times 4, 8, take away 3 times 2, 6. So that becomes my normal. So let me rewrite the normal here. So 15 minus 8, and this is 2. Do you see that part? So we got a normal. Now from this normal, we can actually write down the value for our Cartesian equation as 15x minus 8y plus 2z plus d equals to 0. Now the question is, how do we find d? Right? So now we have to find the value of d. We can find value of d by using any points, passing through the point this and this. So we given 2 points. We can substitute any one of them to find the value of d, right? So in this particular case, I'll substitute the point which is 1 minus 2, 5. Is it clear? I'll substitute this point and find the value of d. So let's do it on the right side. So we have 15 times 1, the value of p1, right? Minus 8 times minus 2. And then we have plus 2z, which is plus 2. Z value is 5. Plus d equals to 0. Clear? So that gives you 15, and this gives you plus 16, and this gives you plus 10, right? Plus d equals to 0. And how much is this? This is 30. Okay. 31 and 10, 41, right? So d is minus 41. Okay, let's write like this. 41 plus d equals to 0. So that gives you d as equals to minus 41. Is that clear? So that is how we are going to get the value of d in this particular case. Clear? So once you get the value of d, now you can write down your equation, which is going to be Cartesian equation as 15x minus 8y plus 2z minus 41 equals to 0. Is that clear? So that becomes your Cartesian equation of the given plane. Perfect. Now we can easily write down the vector equation and the parametric equation. We know the two directions, right? So these are the two directions given to us. They will help us to write down both these equations. So let me write down the vector equation first. So for this, let's use one point. You can use any one of these points. Let's take point Q. Correct? So if I take point Q, then I can write that this plane in the form of a vector equation will be the point itself, 3, 1, 2, plus the parameter, we can say s or t, whatever you want to write. One of these directions, which is 2, 3, minus 3, plus t. The other direction, which is 2, 4, and 1. Does make sense to us, right? And definitely s and t are real numbers. So I'll add it here where s and t belongs to real numbers. Is that clear? So we'll squeeze in the parametric equation also for the very first example, so that's absolutely clear for all of you. So x will be 3, the x value, plus 2s plus 2t. Y value is going to be 1 plus 3s, and this is 4t. And the z value is going to be 2 plus, minus this time, minus 3s and t. Is that clear? So in the very first example, I've actually given you all the three equations. And our strategy will be concentrate on the Cartesian equation since we have to find the normal. It becomes tricky at times. But the vector and the parametric equation are simple to write. Once you get one of them, you can always get the other one, right? So it's kind of translation straight. Perfect. So one of them is sufficient, right? Now let's look into part B. Here, determine again the same, all these three equations containing point A is given to, and perpendicular to a line joining these two. Okay. So we are given a point and we are saying perpendicular to the line joining these 2 points. It means what? It means that the plane is perpendicular, right? So if I have this point B and C, right? And if I extend this, then my plane is something like this. So this line actually goes through it. It is perpendicular to the plane. So that means the direction of this line is normal. So this is, if my plane is pi, then that is the normal, right? So this becomes the normal for the plane. Is that clear to you? So relatively, this question is simpler for us. We can directly find the normal to the plane, which is BC, right? So the direction BC becomes the normal to our plane. So in this case, BC is what? BC is minus 2 minus this becomes, let me write minus 2 minus 2, then 1 minus 1, and 5 minus 6 means 6, correct? So that is minus 4, 0 and 11. Is that clear? So that becomes the normal. Now since we have got the normal, it is very easy to write the Cartesian equation. So we'll say our plane pi can now be written as minus 4x, that is 0, right? No need to write, plus 11z plus d equals to 0. Now to find the value of d, we can use the point given to us, right? So the point given to us is A, which is 1, 1 and 2. So we'll substitute here to find d. So we get minus 4, that is substituting 1, plus 1, y component 0, 2. So 11 times 2 plus d equals to 0. So from here, we get the value of d as 22 minus 4, right? So from here, let's write minus 4 plus 22 plus d equals to 0. So the value of d is, this is 18, so value of d is minus 18. Clear? So d is 18. So therefore, our plane now can be written as minus 4x plus 11z minus 18 equals to 0. Clear? So we got our first equation, which is the Cartesian equation of this particular plane. Perfect. Now, in this particular case, it is not all that easy to get the vector and the parametric equations. Since, strictly speaking, we have only one point, right? We actually need more points on this plane. To find the direction, we need two directions, right? To define parametric or vector equations. So that means we'll need to work out another point B and a point C on this particular plane, right? That's the whole key to this particular question. So let's find these points. The best way to find points is use the equation and take some convenient points. You get my idea, right? So what we could do here is that we could just place, 0 for x, for example, right? And 0 for y, for example. So let's say that the point B for us is, we'll put 0 here. Okay, so I should not write like this. We say the point B is 0, 0 and z, and we'll find z using this equation. Is that clear to you, right? So if I put 0 here, let me rewrite the equation. Equation could be written as minus 4x plus 11z equals to 18. That is the equation. So that is the equation where we know the value of z, right? Correct? Now, if I substitute 0, 0 and we'll find what z is, substituting 0 will make z as equal to what? So if I write 0 here, I get z equals to 18 over 11. Correct? So we get a point here. Let me write down this point B. Now becomes 0, 0, 18 over 11. Does make sense to you? Clear? So that is how we are going to get a point. Now let us substitute this time 1 and then some value and then get the value of z again, right? We'll use the same equation. So if I say point C is, now I'm placing x as 1, right? Let's say I'm placing x as 1, and I'll place y as 0 for convenience, right? So, and then we'll find what is the second point Z, right? So if I write 1 here, in this equation I'm writing 1. So what do I get? I get minus 4, right? And then I have plus 11Z equals to 18, correct? So that gives you the value of Z as taking 4 to that side. So we get 11Z equals to 18 plus 4, which is 22. So Z is equal to 2, right? So the second point for us is 1, 0, 2. So we got these 2 points. You get the idea. Okay, so we got the 2 points. Now, once you have 2 points, you can actually find 2 directions. So it is as good as finding equation of a plane given 3 points, correct? So we'll work with directions A to B and A to C, right? So we could get these directions, right? So we have A. So let's find the direction AB now. So what is the direction A to B? Let me highlight the points. They are already highlighted since I've written them in black here. So point B, which we are going to use, is right there. And point C is right there. Is it okay? So A to B will mean 0 minus this, right? So 0 minus this will be minus 1. 0 minus this means minus 1 again. And we do 18 minus this, so which will be, okay, let's write here. 18 over 11 minus 2. So since this is denominator, let's write 2. Okay, so let's write it again, which is same as minus 1 minus 1, and that is 22, right? So that gives you minus 4 by 11. So that becomes one direction, correct? The other direction is, let's write the other direction, which is, let's say, A to C. So A to C, now we are working with this. So 1 minus 1 is 0, 0 minus 1 is minus 1, and 2 minus 2 is 0. So we get that direction, A to C. So once we get 2 directions, we can write the vector and parametric equation, correct? Now this is all negative. It is, you could write all positive also. So you could actually change this to all positive, 1, 1, 4 over 11, correct? No harm. Since all are negative, it's either way it is same thing, right? So both are correct. You could also write this as all positive, 0, 1, 0. So this could also be written as 0, 1, 0, okay? So we could have written CA or BA, right? So it is one and the same thing. Fine. Anyway, you could use any combination. So remember one thing, that there could be different answers. So there are infinite, there are many vector equations. Because the plane will have so many points, you could have many directions, many points, many combinations. Perfect? Okay. So we can write this equation as a vector equation. We'll use the point 1, 1, 2 plus t times one of these, 1, 1, 4 over 11. Where is it? Yeah. So 1, 1, 4 over 11 plus s times the other one, which is 0, 1, 0. We prefer to write the first term in the direction as positive. So that makes sense if you write all of them as positive in this case. Does it make sense to you? You can, I hope you can write parametric equation easily. Perfect. So I hope these steps are absolutely clear. So in this case, it was kind of critical to find the vector equation. Now let's take up part C. Part C is, we need to find vector, parametric and Cartesian equation of each of the following planes passing through point 4, 1, minus 1 and 5, minus 2, 4 and parallel to z-axis. So when we say z-axis, that means what? Z-axis is, you can take a unit vector 0, 0, 1. So that gives you one direction, right? So we are saying passing through these 2 points. So let's call these points as A and B. And we'll call this is a direction vector. So let's call this as D1 direction. Is it clear? Parallel to this. Let's begin with, again, Cartesian equation. We are looking for normal. So first, let's find the direction from A to B. A to B will be what? 5 minus 4, let me write, minus 2 minus 1, and then 4 minus, which becomes plus 1. So that is basically 5 minus 4 is 1, this is minus 3, and that is 5. So we get a direction vector AB, correct? We already know that Z means what? Z-axis means the direction is 0, 0, 1. So once you get two direction vectors, we can find the normal, and normal will be cross product between these two direction vectors. Clear? And we'll use our method, which is starting with the center number, minus 3, 5, 1, minus 3. Here also 0, 1, 0, 0. And then we'll kind of cross multiply, as you saw last time also. So these terms will be positive for us. The others in the reverse direction will be negative. So we get minus 3 here, right? So we get minus 3, and that is 0, so comma. This is 0, minus 1, okay. And this is 0, and that is also 0. So that becomes your normal vector. So this is much simpler. So we get our plane pi in Cartesian equation. We could write this as A is minus 3, x, minus 1, y. Z value is, there is no need to write 1, of course, and plus d equals to 0. To get the value of d, I'm going to use one of these points. 4, 1, minus 4 is the choice. You could use any one of them, right? So we'll use this one. Okay, substituting, what do we get? We get minus 3 times 4 minus 1 plus d, right? Z is 0 plus d equals to 0. So that is minus 12 and 1, minus 13. So d equals to 13. Okay, so we get, let me write down here itself, d equals to 13. Minus 12 minus 1 is 13. So that gives you d as 13. So now we have the Cartesian equation, which is minus 3x minus y plus 13 equals to 0. So we get our Cartesian equation, right? Now, since we have two directions, it is a very simple thing. We'll just finish it off. Writing vector equation, use this point or that point. So let's say 4, 1, minus 1 plus t times one of these vectors, directions 3 and 5, plus s times the other one, which is 0, 0, 1, where t and s belongs to real numbers. Clear? You can definitely write the parametric equation, which is 4 plus t, 0 value, y value will be 1, minus 3t, this is 0, and z value will be minus 1, 5t, and s. Is that clear? So that completes this particular question, relatively simpler. And now we are almost at the end. Last question for you is to determine the vector and parametric equation when the plane is passing through 3 points. So I'd like you to pause the video at this stage, do this question yourself, and then look into my solutions. sitting on my head. So finally, we are at the end. Hope you enjoyed the wilderness. We had a beautiful snowfall, so I captured this video during that time. Now with fresh mind, let's try to complete this task. Finally, we need to write down vector, parametric and Cartesian equation of a plane which goes through 3 points. So 3 points, let's say this is point A, this is B and C for us. So we'll find 3 direction vectors, A to B. So A to B is what? A to B will be 2 minus 1 and then 6 minus 3, 4 minus 5 will make it plus, right? Okay, so that gives you 2 minus 1 is 1. This is 6 minus 3 will give you 3 and that is 9. Now let's see what is B to C is. B to C will be 3 minus 2 minus 3 minus 6, 3 minus 4, which is 1 minus 9 and minus 1. Now C to A. C to A, 1 minus 3, 3 minus 3, that means plus 3, minus 5 minus 3. Okay, so that gives you minus 2, 6 and minus 8, right? So these are our 3 directions. Okay, now we can find the normal, right? So now we need to find the normal. So I'll go with, actually with these 3 directions, you can definitely write down parametric and vector equations. So let's write down the vector equation. Right, so vector equation will be select a point. So it is a point, let's say 1, 3, minus 5, plus t times one of these, 1, 3, 9, plus s times one of these, 1 minus 9 minus 1, where t and s belongs to real numbers. Clear? You can write down the parametric equation also. Now we'll use this space to write down the Cartesian equation actually. Okay. So we need to find the normal. That's the first thing. So normal will be what? So normal will be, let's say AB cross BC. Okay. So we'll do our standard way, which is 139. We'll start with the center. So we write 3, 9, 1, 3. Clear? And then we'll write minus 9, minus 1, 1 and minus 9. So you end and begin with the same number, correct? So the normal can now be written as, so these are positive, so minus 3 in this case, and this minus and minus becomes plus 81. So we are really getting big numbers. 9 minus 1 becomes plus 1, and this is minus 9 minus 3, correct? So the normal vector here is, that is 78, this is 10, and this is minus 12, correct. So let me use this space to complete the vector equation. Parametric equation you can write from here, okay. Let's change the ink also. So we get the equation as 78x plus 10y plus minus 12z plus d equals to 0. To find the value of d, we could use one of our points. We'll use the same point, 1, 3, minus 5. Okay. So we are going to use the point A, which is 1, 3, 9. Right. So let's substitute 1, 3, 9 in the given equation. So we get 78 times 1 plus 10 times 3 minus 12 times 9. This point is 1, 3, minus 5, sorry. Minus 5. Minus 5 plus d equals to 0. Okay. So what do we get? So we get 78 plus 30. Minus becomes plus 60 plus d equals to 0. So that is 8, 9, 168 plus d equals to 0. So that gives you the value of d as minus 168. Okay. Now we can write down the Cartesian equation, which is 78x plus 10y minus 12z minus 168 equals to 0. Clear? Cartesian equation. Finally, we are left with some space, so no harm. We'll write down the parametric equation also to end this video. 1 plus t plus s, y value will be 3 plus 3t minus 9s, and z value will be minus 5 plus 9t minus s. Perfect. Where s and t belong to real numbers. Good. Parametric equation, which is all this. Perfect. So that is how we are going to write the equations of planes. So finally, we got all the three equations. I hope you have understood the concepts. We began with very simple questions, verifying whether the points are there in the plane or not. Then we looked into the discussion on how a plane can really be defined. To define a plane, we need three non-collinear points, or we need a line and a point external to that line. Now, the last question was, with these four parts, so we are given different conditions to write equation for the plane. And you saw how we could write parametric, vector equation, and Cartesian equation of the planes using different conditions. I hope that really helps. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Share my videos with your friends. Thanks a lot and all the best.